Yeah, thank you so much for inviting me, and I'm happy to share a lot of my work today with this group. So I'm just gonna jump into it. So I guess yeah, you given a abstract introduction. So just a little bit about me. I have been working in different areas in EdTech since 2011. So worked in educational games, started out as an educational game programmer, and then did a bunch of work in learning engineering. And I'll talk more about that. Also worked in education data mining for a while, and then more recently I've been involved in AI application projects, and specifically just understanding more on the implementation side and taking the technology from the lab into the real world. And so check out EdOptimize, Playpower. These are organizations that I've been part of for many years, and I'm based out of Gandhinagar city in Gujarat state in India. um, And so I have four parts to my talk, and maybe I'll try to see. Hopefully, it's not too many slides. But I want to talk about generative AI, what's going on today, right now, and then what's possible with AI in education today. What are the challenges that I see as a person who also looks at some of the research, and then I'll share what I've been working on in learning engineering and using experimentation to improve edtech efficacy. And then lastly, I'll share about smart paper and its impact in India. So just to start off, DeepSeek, it's everywhere in the news, and making great LLM is no more secret. And it's this new paradigm that has just come up, I would say, in last 6 months or a little bit before that, where you have this long chain of thought reasoning LLMs, which are pushing the limits of what was possible. So test time compute, new emerging paradigm. At least for a while, it's going to boost accuracy, I guess. And so pre-training, but if you look at, if you read researchers like Elias Skiver, pre-training may have hit a limit. So, there is more accuracy to be gotten out from test time compute. So this is a very interesting development, and it's showing great results on these different benchmarks. And so I have a slide on benchmark just later. And so some of the things that I'm seeing in state of art and trending is, so one is text and code models, and that's where these long chain of thought reasoning models, I think it's doing really well. In image models, I've been seeing, I don't know what's the latest, but one of the key things that I observed is much faster image generation, with specifically with this flux model, which is seems to be everywhere in production now. So much higher realism with low parameter counts. For video, what I'm been observing is that the Google's model seems the best, probably because they have a lot of training data, and there is a um, maybe everyone is still again using same method. For audio models, there's something very interesting going on right now, where with very less parameters, with less than, for example, 100 million parameters, you can get outstanding performance, and this is happening with model distillations. And one example is a model called Kokoro. And there's more stuff happening with 3D worlds. I think the researcher Feifeli startup doing some 3D world generation. Uh, I'm always looking for good vector drawing AIs. I don't think that's still there. And there's, of course, a lot more in sciences, which is beyond my expertise. And so some of the key issues that, as I work with these systems more in practice, that I see is that generalization out of the context, training context, is so difficult. And it's much more apparent when you look at image models, like, the 10-10 clock. I mean, it's a classic example. If you go to ChatGPT today, right now, try to generate a clock with like any other thing than 10-10, in the configuration, and the model just not gonna do it. It's like, no matter which model you try, no matter, how much you try, it's because all the training data is for these clouds. And so this is, I keep seeing this as a big limitation. And it's also, to me, it's something that shows some kind of inherent limitations. And another big thing that is coming out is verification of the AI output, and specifically with DeepSeek, where it appears that they've used some a set of verifiable problems, which is something that generally enhances experimentation speed. Okay. And so some of these things, yeah, so I think these are hard things, like how many hours in strawberry is still hard. Figure drawing I particularly find, specifically working in education, if I want to generate questions like geometry questions with figures, I can't do that. I can maybe write the text but not figures. um, or maybe there are some ways to generate code, and I think there are more ways to do with integrations and sort of tool use, rather than just LLMs. And um, and also what I've noticed is one of the ways to have even higher accuracy is to use really high quality training data, and so Microsoft Phi is an example. So some of these things are interesting, but I also find that LLMs use a lot of compute for simple things. So it's like, using a crane to hammer in a nail. So who knows whether that's useful. And then the whole agent thing that's going on around right now, things like model context protocol, where people are trying to make data more accessible to models in a systematic way in computer use. So I think these are all very interesting things. And as I work in the education domain and think about AI in education, then I kind of come back to psychology and think about whether AI can model human thinking. And this is the example library called Tiny Troop by Microsoft, and it can let you kind of simulate conversations between virtual people, and they try to show use cases like you doing UX research, etc. But can it really model human behavior? It's a big question. And so we've been, people been using benchmarks like R. If you look at some of these benchmarks, to measure intelligence, but I think there is a much more to be done specifically on the benchmark side. And so as I'm now going to jump into this, connecting this with education, is and I have some kind of interest in history in EdTech, and I'm really fascinated always when I look at Plato as the first EdTech that was built, and it was really a computer built only for teaching and learning. And this is a computer that influenced Xerox and that influenced Apple. So I think there is a lot with EdTech and technology and learning, and specifically how learning theory informs, when we think about EdTech, yeah, learning theory informs EdTech, but it has also informed AI development in general. And as AI has evolved, and EdTech has sort of evolved with it. This is just very recent news about effective use of AI in education, and how do we measure. And there is also, of course, possibly hype. For example, in this study, an after-school program that uses AI was compared with control condition where there was no after-school program. So after-school program itself would have a significant effect. But I think there is, there is rapid kind of need for experimentation in this space. And I'll come back to the experimentation with learning engineering. And also, I'm seeing like people are trying to understand this technology more, and AI's impact on learning. And it's not completely clear, right? Someone who wants to sell the AI will say, oh yeah, it's a great tool. But here's the recent news, and 42% students says that they should not be using AI to write essays. That's great. People understand now that using AI, we need to understand when using AI is not great for our learning. And I think when students understand that it's a really nice environment where we can be more sure that AI is going to give intended results, or effective experiences. Um, and so when we are working with AI in education, uh, and then you start also thinking about benchmarks, because, for example, this is a study where students used a chatbot, And so chatbot needs to have certain pedagogical knowledge. And so here's a very interesting benchmark on pedagogy, and that's from AI for education.org. And this has evaluated, and this is, if you look at their methodology, it is using teacher training materials and parts of that, and evaluating LLMs against those things where you are teaching. So I think this is very innovative, and this is something uh, interesting, because what kind of conversations in the chat based experiences are effective is something I think is going to be a big research question, which will need a lot of experiments and studies to understand. um, and so yeah, so overall, and these are some of the things I guess I mentioned before. There's some of the things that are hard, but specifically when I look at education use cases, factuality is a big thing, because when you are using AI to teach something to a person who does not know the correct answer, right? As a prompter, you often know, if I'm using AI for coding, I know I know how the code should be written. Otherwise, I'm going to have to learn it at some point. And so that is, I think, a big thing. And maybe there are like approximate ways, but there is no way of verifying information with LLMs right now. So I think it's definitely a big, I believe it's an open research area. Also with mathematics, it's the it's this is maybe part of the weirdness of LLMs, is they can make trivial errors while knowing all the things, uh, which is also kind of its inherent architecture. But I believe that it's going to be important, and I'll just share maybe an example later on. For example, in system like smart paper, making a small mistake in mathematical sort of understanding, or handwriting recognition, can have a catastrophic effect on the overall outcome. Drawing diagrams, I'd really like to know ideas from people if they have drawing diagrams. And one of the things that I've kind of observed uh, with voice recognition for assessments is that AI is not very effective there right now, specifically for assessment part, and not for text to speech or speech to text. But when AI is being used to assess the reading fluency and whether the children are saying the words correctly, uh, AI cannot identify that and will tend to correct the mistakes of children. And this is because it's trained like that. But so it's not very useful at the moment for assessments or to really do it well. And also with handwriting recognition, of course, it's a challenge that I am personally facing when we take the AI, use any of the best models, but they don't understand children's handwriting necessarily. And so there is a lot of course, gap when we go out and actually apply. So I think, yeah, these are the some of the challenge areas. So across all this, there are challenge areas, but I also feel that the experimentation is the only way that can establish the efficacy. And so our approach has been for a long time to design EdTech in a way where we can run experiments, repeatedly run experiments, rapidly run experiments, and establish efficacy. Right? So, here's there is a tool called Upgrade, and it's developed by Carnegie Learning, and we also are one of the contributors in this open source project. So it's a tool to manage A/B tests in educational applications, and it's an open source software. If anyone wants to try it and check it out, know any information, let me know. And if you have an EdTech platform, you can use Upgrade SDK, and you can connect it with your EdTech application, and you can configure the application in some simple ways and create things like experiment points where you can run A/B tests in your application, and collect the results and understand the impact of changing different features. And this is, I think, when we are building new AI experiences, and like just ability to rapidly experiment with different variants, I think is going to be important to rapidly improve the efficacy. And so yeah, I'll jump into now the learning engineering part and talk about the how we are thinking about running experiments uh, and improving both theory and the software's efficacy with that whole cycle. So I'm gonna show this by example of a learning game. So this is a game. This is a very latest version, but it's a game I started also working on, I guess, many years ago or a decade ago. And we ran a series of online experiments in this game with and a number of studies have been published. And all these experiments were with very high sample size of 10,000 people or more. And these were all like online experiments and with anonymized data, but the game was back then hosted on brainpop.com, which is a popular game, the educational game platform. And so in this game, Battleship Numberline, students are given problems of finding fraction on number line. And here you have to find half. You tap, pineapple will drop and some robot will so go die. And so it was a fun game. Kids love blasting things, and people, lots and lots of them have played it over the years. So we had things for fractions. You can practice whole numbers or decimals. We had different things on number line, different types of exercises. And so our goal, learning engineering research goal was that how can we improve the seed time of the game and also maximize the learning gains in the game. And and the and so I'm gonna share like one of the initial experiments that we ran to understand like how to maximize, how to get the maximum seed time, and which was the initial metric for optimization, is we ran an experiment with difficulty. So if we made the game more or less difficult, we wanted to understand how that would change the engagement. And we knew from early studies, like chess game, uh, if if you are as good as your opponent, you're gonna enjoy playing the game more, and less so if you know more than them or less than them. And so expectation of some kind of inverted U, where in the middle there is a sweet spot, and that's the maximum output of the game or efficacy of the game, and our metric was CTAC. And we ran this experiment and we expected an inverted U, but wow, we found that children liked it when it was really easy. And they kept playing more if it was like easy. Yeah. And so maybe it was just like big ships blowing up. And so then we ran more studies, and this was in collaboration with I was collaborating with researchers from CMU, and we ran a series of studies to understand what difficulty was, and how it related with different things, uh, and like even things like novelty, and we just ran more experiments to understand better. And the approach was really to be able to run as many experiments in our technology as possible so that we can rapidly improve the efficacy. And so then we ended up uh, running an experiment where AI was used to run the experiment faster. And we ran so for it like and some of these algorithms, and they're called multi-arm bandit family of algorithms. And so if we were running a big experiment and we wanted to test more things, we wanted to test more theories, but then it's a really big experiment with many conditions in a factorial, and it's just too many conditions, and you just don't have you didn't have AI people, and I don't know whether that would work really, or infinite actual users. And so that these algorithms that we used, and this is also used by to optimize advertising designs, is to use some sample data to find out which condition may be optimal based on the outcome measure, and then kind of go more into that side. And so just on the bottom, if you see that chart, that first is random assignment, so every condition gets the same. Second is a kind of good, the condition that's most effective likely is like, kind of picked out. But the third one is something where you can see, I mean, it's almost like the AI got stuck there. And so it was kind of interesting to see AI running experiments, but also getting stuck in some local minima. And so it is, so this is something that we haven't really pursued, but I think it's important because now with AI, and so one of the biggest challenges, so you might think, oh wow, we can run all these experiments, but the biggest challenge was that building the variants, because we want to run a great experiment, test many theories, but building all the variants, like for according to each theory, that was a lot of work. And I'm really hoping that AI programming brings that workload down, and you can do it more rapidly, because but then I think like that challenge is still there. And so specifically to address this challenge, we released this tool called Resource. And Resource is a tool to quickly design education experiments. And our specific focus at this point is running experiments on AI tutoring experiences. So where you have a prompt, and then based on the prompt, there is a chat session, and then we're trying to optimize which chat session is the most effective one. But system can also experiment with videos and or kind of documents. So it's a very simple A/B testing tool, which also has built-in outcome measures. So you have pre-test and post-test, and you can configure them. So you can very quickly run a small study, and it's very easy to define it. So so let me just show how that works. And so, here's, for example, it's a very simple interface where you can define experiment details, and then you can give the prompts. For example, and I'll show a real experiment we ran online. But you can just give prompt conditions, and the version that's live right now, it's on resource.education. You can try it out, it's free. And so you can have YouTube video as a condition. So if the experiment link goes to 100 students, some will see YouTube video and others will see a chat session. So and everyone will see pre-test and post-test. So here you can set pre-test, you can have a MCQ, open-ended question, and all of this data you can export from resource after you run the experiment. And you can also ask users for feedback. So, and when a user gets this experiment link, they will see introduction, and then you have a survey, right? You have pretest, and then there's this chat experience. So whoever's if this is a student, and if you're experimenting in a classroom, then some students might get one kind of chat tutor, other might get another type of chat tutor, and it will run for if you configure to run for 10 minutes, and run for 10 minutes, and then user can end the conversation. Yeah, and then you get some feedback. Yeah. So this is the first experiment we ran, was we just ran with 8 people, and it's on an online platform called Prolific. And the experiment was about teaching experiment design, and the tutor, and this was designed by my colleague Derek Lomas, who's professor at that university. And so this is an experiment where there are 2 chat tutors, and it will go step by step through different steps of the experiment design, the hypothesis, help the user refine it. So at the end, so when we looked at the data, we saw, one of the feedback which was really helpful from the user was that it's a good tool. It gives suggestions I wouldn't have considered at all, and it seems adaptive. So like, when thinking about confounds, for example, the chat tutor was able to give good a sense of, something that you would forget. And so this is something, so our hypothesis is that we should be looking for or we want to be looking for what type of conversations are effective. And maybe, if we, for example, if this tutor went to many students or somehow it went to many individuals, then I think, like, with some analysis, we'd be able to figure out in principle what contents of the chat are leading to effective outcomes. So this is all great, and I keep, like, if you think, oh wow, like, you can use learning engineering to continuously improve edtech, and technology is everywhere, but it turns out, and I'm from India, so maybe things are a bit different here, but paper is everywhere in classrooms in India, and technology access varies so much, it's extremely. And so, we kept thinking, we've been thinking about paper for a while, and why we should, build technologies to support it, because I kind of feel that paper's been sort of left out in terms of support for technology. But with AI, within specifically with new AI models, it's becoming much easier to process unstructured data. So I think it's really good, and we can do more of this. And so this is the final part, and I'm going to talk about smart paper and AI in assessments. So this is just in, I think a few days ago came in news that after many years, Sweden is investing back in books, and there's so many studies now showing more and more how reading on paper, writing on paper, thinking with paper as a tool is effective. And here's a study showing how writing on paper enhances math and language learning. I'm sorry, this study is about mathematics, and so you can see from control to intervention. This is a very small study, I believe it's only 20 to 30 individuals, where it came really close in terms of significance. And just this was just like a reminder to solve problems on paper before submitting digital homework. And like, it's much more natural to do mathematics on paper specifically. Here's another article from last year, but I think this cites a lot of credible studies, and it shows that the brain's activation patterns are different when reading on paper. And you can, of course, also try just and see your distraction level when you go from digital to paper, and it's great to watch. So this is the reason why we felt that building a paper digital bridge was is important for future of edtech, at least until, like, digital access and efficacy is established, because there is now issues with efficacy uh, digital compared to paper. And so the space that we've been trying to work on is first digitizing paper assessments and then formative assessments right now. And there is a lot of activity that happens on paper. And I think some of it is more reliable, more easier, more straightforward to digitize in terms of scalability. And if you look at, for example, notebooks where there is a lot of unstructured information, so the more unstructured data, it's like, there are more challenges. And so we are right now in assessment space, we're trying to digitize that. But I think there is much more to be learned, or to be done by connecting paper and digital overall in that space. So with smart paper, you just click pictures of these assessment sheets, smart paper assessment sheets, and we process each item uh, differently. And we have this template processing engine right now that's operating. And it's, so we talk with teachers, it's always easier to view our paper sheets in our classroom or kids. So this is the story in Rajasthan that has happened now for last 2.5 years. And so this worksheet digitization tool, so you can see some pictures on the bottom of how it works, right? So you see a photo of worksheet, and it's from pretty far away, but yeah, the worksheet is straightened up, the pages are aligned, and it's examined. And so this technology has been adopted by a state government, and for last 2.5 years. So you scan many papers for nearly 5 million students. And this is something that has become practice in a state that's very big. and where digitization of data is, and reliable digitization. I think this one of the key things here was, because if you develop a system that, so I think scalability and reliability. So earlier state had a system where, people could just manually enter the numbers, but that's not very reliable. So, that was solving an issue for the government. And so this is great. And, here's where the data feedback loop was established at a very massive scale in public education infrastructure, where, these assessments are becoming now data feedback loop and so overall on the system. And if the cycle is going on, and this happens 3 times a year, of course, if that happens more in a formative way, then it's going to be even more beneficial. But doing this as such a big scale with 300,000 teachers, 51 schools, so it was a big effort for a state, and it's been going on for a while. And so it's very simple, millions of kids do assessment on just one single day, and it's very challenging to have all of them on digital, or just even with some kind of operational efficiencies. But yeah, these are some pictures more recently. And so these are the major type worksheets, and these operate at much mega scale. And the one on the left, so it's interesting that we learned that the design on the left is more friendly for younger children who do not really understand how OMR works. So they will just tick all the boxes and they will not really understand. So sheet on the left, in fact, it provides more reliable learning data from a younger child. So this is also part of the initiative. And of course, the system has to be very reliable because the way people take photos, the lighting conditions, the cameras, and it's really varied. And specifically in geography, where you have phones that are old, could be 5-year-old, 6, 7-year-old. Other states tried it, but they used applications that used a lot of compute power on the device, versus we used a cloud-based model, which was successful. And so there is a lot of things, there is a lot of impact that's also being measured by others. And But I think one of the drivers is data feedback loop, and also not just in classroom but also to parents. And this is a great initiative by state in that way, that the data from this entire effort was also going back to homes, where they expected that that would be additional efficacy leverage. And so that is for objective assessments. And now we have this subjective assessment system, where you can create papers, and you can define scoring rubrics. And that's how we are using LLM for grading. And so you can define a scoring rubric. You can also generate paper sheets, paper worksheets in Smart Paper. And scoring rubric is, will help do multi-point grading. And and now with latest models, you can also do math OCR. And so that enables a lot of things. So you can read math, you can read, and of course you can just also use rubrics to grade manually. So here's a math assessment, right? And the AI's ability to digitize these responses gone through, I think, like, it has improved quite a lot, which is now enabling us to make this platform which is broadly applicable and not just a written items, which is has been a limited use case. Here's an example from physics, and it's a one-page assessment. And the very powerful thing is that if you have if you have 100 kids, and in some Indian classroom, that's a reality, and you just give a 5-item test that's not MCQ but descriptive and actually shows the thinking process. I think it's a much high richer information as an instructor. And also on top of that, what we are doing now is also providing feedback to the learner, making the assessment process, hoping to make that more effective. So it's not um, just the grades that they get back, which is frankly not too useful, but still popular.
Nirmal,
And
5 more minutes, please.
yeah, just I think, yeah, it's at the end. So and so this is, and so we, as we are looking at this whole like image data, um and this is what some of us have been calling ImageNet for education, is to collect these item responses from papers for specific questions and then understand what are the patterns. And so I'll give an example of this one question. Multiply 2i plus 5 times 2i plus 5, and we gave an exam to kids, and this is one of the questions, and there were 100 kids, and so we did some sort of clustering analysis of this, and what we find is that okay, there are these, like, distinct mistakes that students make, and you can see, and it's also correlated with teacher who is teaching. But the most interesting part is that if you ask an LLM, even the reasoning LLM, even the top, O1, I asked Pro1, I don't have that Pro1. But none of those models can tell these misconceptions. They have no idea, and they'll give you, like, very, you'll think a lot and keep thinking, but wow, they just don't know how people make mistakes. And so I think there is more to be learned here, because LLMs don't seem to understand how people make mistakes and learn. So I think I believe that this is something where, it's a kind of data that shows how people learn, and something that LLMs can't produce. So I'm finding it, interesting area, and more like an unexplored area for education data mining. So I think that's all. And check out our work. For Smart Paper, you can visit smartpaperapp.com, and if you want to try resource, it's at resource.education. So yeah, thank you.
Thank you so much, Nirmal. Fascinating and lots of information. Before we go on to ask from the audience, are there any other links, applications, software, if there's a trial version or free version of any of the stuff you've shown us that you could share, or is it all in this website, smartpaperapp.com?
Yeah, it's all in smartpaperapp.com, and there is a lot of free credits that we give on sign up, even for Gen AI features. So feel free to try it.
Excellent. Thank you. So I have lots of questions, but I'd like to see if anyone else has any questions. So Richa or any of our participants today, feel free to either use the microphone or put it in the chat. I haven't seen other questions, so if I've missed any, please let me know.
There's a long list from Ree, actually.
Oh, okay. From whom? Sorry?
From you.
From me, yes, but I'd like to see if oh, Familayo, please, do you have anything to add, please?
Yes, thank you very much. Well, like you said, lots of information. So I'm just wondering now, when it comes to handwriting of students, some can be very, clear, legible. No. So what effect do you think, or what impact does it have on the accuracy, basically, of the app?
So I'll just tell you a few things that we have seen. So we were, for example, looking at English essay grading, and we saw some handwriting which was extremely dirty, which was a human could not read, but a computer read it much better. So I think with sufficient data, it will do really well. What you need to ensure is that for that population there is data, and I think that's a bigger challenge, that the LLMs, although yeah, I think so it will differ from geography to geography, and you would just need to benchmark, I think.
Thank you very much.
So just following up on that, Nirmal, if I understand correctly, the model would need to be trained on handwriting from that population, ideally, in order to be able to recognize. I have another question. With the types of exams, the worksheets that you showed us, are these closed-ended questions where there's one correct answer or multiple correct answers, but we know what they are? And then you have some kind of a key that the model has that, there's a rubric that the model implements on that, or is it even more open than that?
Yeah, I see. I think, yeah, it's not really open-ended, but it's more like close-ended, and you have defined rubric. And then I think the alternate answers is still a missing feature in our platform.
Mm.
But I guess, well, yeah, what you mentioned about open-ended is maybe, it's something else that we would build, where maybe there's much more flexibility from the teacher to define how they want the grading to work. I've seen some essay grading new tools where you can upload a much more nuanced rubric where you have, categories and kind of stuff, A, B, C, D. So it's like a grid format. So I've seen some tools explicitly supporting that recently.
Could you maybe go back to, there was a study that you showed, I think it was in Africa, a country in Africa, but I didn't quite understand what the findings were. Maybe you
Yeah,
could explain. It was towards the beginning
yeah,
of your presentation.
this one. And
Just,
this
that would be useful for everyone to know a bit more about that study.
Yeah, this is something that World Bank also published, and this got around in news quite a lot. I think a lot of people were quoting this and saying, "Oh, AI is great" and everything. And my question was that you tell me what the control condition is. So this was, students in a control condition, students in treatment condition get an after-school program which uses AI, and control condition does not use after-school program. So I felt like, after school program itself can be
Right.
very fair. uh, but I haven't read all the entire study, but this is something that I've read kind of overall. But I think this is a one that got publicized quite a lot recently.
You also, there was an acronym you used even earlier on called TTC.
Yeah, there's a
What
test
does that
time compute.
mean? What does TTC mean?
So yeah, there's a test time compute, and
Oh,
what's happening. Yeah, I think, like, that's, yeah, at the time of your prompt there is a lot of computational thinking, and that's what people are calling. And there is also test time training. And that's specifically for RKGI. So if you see some of the winning models in RKGI, they use test time training where on the prompting time there was a very small training step, or maybe one step or something. So you just do some training and then you do inference, and so that gave a lot more accuracy even if your model was small, like even if it was 3 billion parameters. So I think that's another thing related.
thank you. So the last thing I wanted to, I guess, comment on and just hear your response, what you think. What I found was, and what I'm getting from your presentation as well, and I found from my experience, is that generative AI, and now I'm talking about the general purpose LLMs like ChatGPT, not models that are curated with, trained on curated data and are specific to one role. I found that it's very good if I have a detailed rubric. It's very good at providing that kind of assessment and feedback on specifically on adherence, on following instructions or following a template. But the trouble starts when I'm asking it to look at correctness and accuracy of content, right? That's where we get hallucinations, and that's where we have to be a lot more careful. And that's where we probably also need to have more curated data. So this difference between adherence and correctness to me is, this very massive gulf, because to me, generative AI is actually better than people. This is something that I'm trying, a hypothesis I'm testing right now to see, because my hypothesis is that ChatGPT is going to do a better job at assessing whether students have followed the instructions of an assignment, regardless of the accuracy or correctness of what they wrote. It's going to be better than people. It's going to be more reliable, more accurate. Whereas with correctness, I suspect that's probably not the case if we just, throw different things at it. But like, what are your thoughts about that? Because that's why I also asked about the open-endedness versus the closed-ended nature of the worksheets. Because if they're closed-ended, it makes sense to me that we can just trust the generative AI. So just what are your thoughts about that?
So, and maybe I don't know how to answer directly, but for our use case, for example, for grading, what we are trying to do, and the reason why we went with rubrics, we are trying to use model more as a classifier, where I have a student response and I have a rubric, and then I just want to know from model whether it exists inside or not, and I don't want model to use its own reasoning or something. So I was trying to use it that way, just to have a very consistent and reliable kind of thing that I suspect that model is very good classifier, right? And it's just be able to tell me that does this exist or not, or maybe on some scale. And so I'm just trying to figure out how it could be most reliable in different
Mm.
use cases. That's how I'm thinking about it. Because even for maths, I think, yeah, and it somehow, like, it will blindly follow. I mean, LLM is not dogmatic. I think, like, it's also interesting is it's sort of gullible. And I think that's part of the challenge is like you can tell it to believe, like, to stick to something, but you just don't know whether it will. So, yeah.
Yeah, I think there's no escape for the work that we need to do, which is to figure out what we want to teach and what kind of answers maybe we expect. And so it's a collaboration or a cooperation, right, between us and the AI in a way. I'm going to have to leave soon. Unfortunately, I've made Rich a host, but does anybody have any other comments or questions? It's a really interesting topic. You know, David, please, you have a question?
Yes, hi everyone. So I got a question. I work with some universities here in Colombia, and these universities usually use LMS like Moodle and Brightspace. So my specific question is, how does Smart Paper integrate with Brightspace and Moodle?
Interesting. We don't have integration with those platforms, but maybe we should look into it and see if we can, and potentially, we can release it as a feature. Yeah, we don't have integration right now.
Okay, okay. And in the next like 6, 12 months, which are specific features that are you planning to launch from Smart Paper?
So we are going to improve our rubric-based grading. So right now, what we have is you can define rubrics, but the AI is not telling which rubric is, specifically telling you which rubric it gave you points on or not. And so we just want to make it very transparent that, you can see a list of rubrics and then you can understand clearly that AI, just gave points on this rubric. So the grading process becomes transparent. So that's our kind of initial feature, I think, which we are trying in a few months. And then just have more usability features like, being able to import your own assessment that you made in Word. And so you can import in Smart Paper, and then, you can hand out paper assignments outside. But I think scanning within external platform is something that we haven't tried yet. So like, scanning and all of that happens within our platform, but we'll be providing more like a data export functionalities in the beginning, so people can at least manually take out data and use it in other platforms or communicate things.
Okay, thank you. Thank you so much.
So Ree has already left, and with the instruction that I need to end the meeting when it's done. Any other questions or any other things? There were a lot of how do you ensure and verify correctness of responses? I think you have already given a lot of answers. One thing which I actually have you approached other states of India, because I think this problem, the digital divide, or those kind of things, where the schools, lot of schools, they do not have basically, PCs, personal computers are not there, computer labs are not there. So I think this is a very good idea to have such kind of things where, uh, you can actually do away with smartphones. You don't need laptops, you don't need OCRs and, those kind of things. So have you approached other states as well?
So I think this ecosystem is so complex that getting into, like, the whole, like, there is so much complicatedness to the whole process. But we did do a pilot with Andhra Pradesh state, where in one of the recent assessments, they gave one district to us. So that was all Smart Paper, and remaining were continued with the old OMR methodology, where the sheets go back to the scanners and all. So which takes roughly maybe 3 weeks, 4 weeks to digitize, and ours was just instant. So
Yeah.
they also, because the data feedback is then much faster, and if they're using it in their class assessment, then it's even, like, more helpful in a regular basis. So the teachers definitely found it helpful, but implementing that in that entire ecosystem and like I think that's definitely a challenge overall.
Yeah, I've worked with the OMR thing in 2009. I was,
Wow.
Gujarat government introduced OMR and it was very messy. It was very
Mm.
difficult. Yeah. So any other questions, any other comment, remark, David? Yeah.
No, I'm done.
Okay. So let's conclude the meeting. Thank you so much, Nirmal. And you can connect with the people who were here and David and Sanlio. You can connect with Nirmal if you want. Thank you so much again.
Yeah, great. Good
A
to
good
meet you.
night. Have a lovely day wherever you are. Yeah.